Okay, welcome everybody. In the name of God, the most gracious, the most merciful. So in this video, we're going to speak about the exponential graphs, and we're going to sketch the graph. So we're going to how to sketch an exponential graph in this video. So let's look at the properties of exponential graphs. So we've got y is equal to a times b to the power of x minus b plus q. So the a always gives us the shape of the graph. Now in the exponential graph, if the a is more than 0, meaning it's positive, the graph is going to be basically above the asymptote. Okay, and then if a is less than 0, it just means that the graph is below the asymptote. So all that means that if a is more than 0, the graph will kind of look like this, and that's the asymptote. And then if a is less than 0, the graph is kind of going to look like this, where it's below, the graph is below the asymptote. The asymptote is a line that the graph never crosses. The b value tells us something very important. If the b is more than 1, we have an increasing graph. And let's say that's the asymptote, for example, and this is how an increasing graph looks like. So that's how an increasing graph looks like. And then if b is more than 0 and less than 1, so it's more, so for example, it's a fraction. So in this case, b is a fraction. So if b is a fraction, we have a decreasing exponential graph. So you see that's the asymptote, and the graph will look like that. Okay, so let me just clarify something quickly. So for the increasing graph, let's say that's the asymptote. This is an increasing graph. Okay, whereas the x values increases, the y values increase as well as we go from left to right. Okay, and in this case the graph is above the asymptote. Then so if the graph is above the asymptote, a is more than 0, right? So in this case, b is more than 1 and a is more than 0 for this graph. And then if you want to look at for this graph, if you do a reflection, if you go below the asymptote, that means a is less than 0, meaning a is like negative. That's just some of the properties of that graph. Then let's say that's the asymptote, and then for a decreasing graph, the graph will look like this, meaning that as the x values increases, the y values decrease. You see, as the x value increase, as the x values increase, the y values decrease. The y goes down while the x go up or towards the right. The x is getting more, but the y is coming down. Okay, and then the top, if the graph is above the asymptote, that's a is more than 0. Then if the graph is like that, we have a is less than 0. As if the graph is below the asymptote. Okay, that's just some of the properties of the graph. And then the p-value. Now the p-value is for horizontal shift. Okay, the p-value is for horizontal shift. So remember, if we go 3 units to the left, you're gonna plus 3, and if you go 3 units to the right, you must minus 3 by this value. Okay, and then the q is for vertical shift. So if you go 3 units up, you're going to plus 3. If you go 3 units down, you're going to minus 3. Make a very important note of that, please. Let's sketch a exponential. So 2 to the power of x plus 1 plus 1. So let's go. F of x is equal to 2 to the power of x plus 1 plus 1. So the a value here, okay, first, what is step number 1? Step number 1, we're going to sketch the exponential. Is you must first, what is the asymptote? So step number 1, get the asymptote. The asymptote is always going to be y is equal to q. The q value here is 1. So therefore the asymptote of this graph is y is equal to 1. So you can, if you draw the graph x and y, Cartesian plane. 1 is about here, so then you just draw your asymptote like that. So that's the asymptote. Now number 2 is the shape of the graph. For the shape, you look at the a value. The a value is 1. If there's nothing, just the b value, right? The b value is always the base of the exponent. The b for base of that exponent over there. The a value is before the b, so that a value is actually 1. If there's no number, it means that there's a 1, and that 1 is positive, is more than 0. So a is more than 0, therefore we know that the graph lies above the asymptote. The graph lies above the asymptote, and we also know that b is more than 1, b is 2, so therefore it's an increasing graph. So if the graph is increasing and lies above the asymptote, we can predict to ourselves that the graph is going to look like this. Okay? And we got it from this principle where if b is increasing and a is more than 0, our graph will look like that. You see how easy it becomes? Or you see the link or the connection, how to analyze it. So b is more than 1 is an increasing graph. The graph is going to look like that. So we know we can kind of predict how the graph is going to look like. You understand? Step number 3 is the method. The method you can either get the x-intercept and the y-intercept, but the method I want to use is called a table method. The table method. Okay? I like to use the table method to draw exponential graphs. Okay? The table method, you just draw your table. You got your x and your y, and you go minus 1, 0, and 1. Okay? If x is minus 1, what is y? If x is 0, what is y? If x is 1, what is y? And then you just get your corresponding y values. And then once you got that, you just plot and draw the graph. Okay? If x is 0, you're gonna get your y-intercept. Okay? So anyway, so if x is negative 1, we got 2, negative 1 plus 1 plus 1. Negative 1 plus 1 is 0. 2 to the power 0 is 1. 1 plus 1 is 2. So that's 2. 0. 0 plus 1 is 1. 2 to the power 1 is 1. That's 1 plus 1 is 3. 1 plus 1 is 2. 4 is 5. So 2, 3, 5. So if x is negative 1, this is negative 1. Y is 2. So that's about there. 0 and 3 is about there. And then 1 and 5 is about here. And we can draw our graph based on the shape that we got. And that is 0 and 3. And you can see that in this graph, there's no x-intercept. And that is the graph of f of x is equal to 2 to the power of x plus 1. Okay? And that's it for the sketching and the properties of exponential graphs. Oh yes, I forgot to mention, that's y is equal to 1. Okay.